All right, get your essential question written down. We're going to try to get through as much of this as we can today. My goal is to try to get us through, it looks like, example 12. Okay? I don't know. What page is it on?
139.
139. That's where you're at. There's a bucket back there that says pencils on it. It's purple. It has bunnies on it. Alright. So, what we're going to talk about today, it's sort of new and sort of not. Okay? You may have, I know that this is the group where some of you guys got messed up in middle school with Algebra 1, and some of you guys ended up taking it with Mr. Prickett, and some of you guys ended up not doing that. So we kind of have, so this is one of those topics that may have gotten caught in there where you picked it up or you didn't. Okay? They should have done some arithmetic. It's not something technically I'm supposed to cover in the Algebra 2 part of the course. Okay, but we're going to review it anyways. We're putting this up. We normally would do this, even though it says Unit 1. We dumped it into second semester, so we get logs in first semester. And last year we tried to put it before SBAC testing, and then we had to do the whole thing in 3 days. Okay, but we don't need all of trig for SBAC testing. So we're trying to get this, we tried to put it the first couple of days. It's pretty easy stuff. It's very formula based. Okay. So you're going to have some formulas you got to learn and learn how to use them. Hey, Diamond. Do you have a notebook? A math analysis notebook? No? Okay, I'll get you one. Why not for today you sit right there. Okay? So it's very, very, like I said, it's very, very formula based. Okay? So it should be an easy way to start and get a good test score right off the bat. Okay, you got a whole bunch of stuff to fill in. Go ahead and start doing that. Okay, we ready? Okay, so a sequence, and so what happened is we don't like the first section. Notice we went to right to 8-2. So we picked up some of the vocabulary that was in section 1, and then and then we just kind of squished it in here to section 2. So these are things that would have been in the first section in the chapter. So a sequence is a list of numbers or terms in a pattern. For example, 3, 5, 7, 9 is a sequence starting at 3 and increasing by 2 each time. Okay? An infinite sequence is a function whose domain is the set of positive integers. The function values. So this notation right here is just the way we write it. Is the algebraic way to write a sequence. It means a sub 1 for the first term. A sub 2 is the second term. A sub 3 is the third term. A sub n is the nth term. Okay. A finite sequence is a sequence in which the domain of the function only consists of the first n terms. So that means it stops after an n number of terms. Okay, so maybe 5 terms or 20 terms. A series is the sum of the terms in the sequence. So when we add up the numbers of the sequence or the terms of the sequence, that's what we call a series. Okay, you got to write that one down. So fill that one in. Alright, so we can get very specific on types of sequence. So rather than just a random sequence, we have one that's called arithmetic, and there's another one called geometric. We'll deal with geometric towards the later part of the week. It's a sequence whose differences between consecutive terms in the sequence are the same. Okay? So this is the sequence, and that's the notation for a sequence, is arithmetic. Basically, it says if the difference between the consecutive terms, so meaning the difference between the second term and the first term, is the same as the third term and the second term, and the fourth term and the third term, and so on and so on and so on. D stands for what we call the common difference. Okay? So we're going to determine if the sequence is arithmetic. If it is, we need to find the common difference. So as we're doing this determining, we're going to actually find the common difference. So what I'm going to do is I'm going to take the second term and subtract the first term. So what's 11 minus 7? 4. Perfect. Okay, and then I'm going to keep testing. I usually test it about 3 times to make sure I have the same common difference. So then I do the second term minus the third term. So, the third term minus the second term. So 15 minus 11 is what? 4. Good. And then I'm going to do the fourth term minus the third term. So 19 minus 15 is what? 4. Did they all match? Yeah. What is the common difference? It's 4, right? Because every time we subtracted, we got 4. Okay, so that's the answer that they're looking for. So it would actually be yes, it's arithmetic, and the difference is 4. Okay. All right, let's look at example 2. So let's see, -3 minus 2 is what? -5. So we're looking for a -5 difference. Then we've got -8 minus -3 is what? -5 again. It's looking good. -13 minus -8 is what? -5. Does that one work? Yes. And what's the difference on this one? -5. Okay. All right, let's look at the next one. So on this one here, what numbers am I going to subtract first? 4 minus 1, which is 3. Okay. And then I'm going to try the difference again. I know I didn't do d equals last time. 9 minus 4, which is? 5. Does this one work? No. No. Okay. All right, the next one's a little uglier. we've got some fractions. Okay, so really, I would, instead of saying 1, I'd probably say that that is 4 over 4. Yeah, so 5/4 minus 4/4 is what? 1/4. Okay, then I want to look at this. So instead of writing 3/2, what's that in fourths? 6/4 minus 5/4 is, so it's looking good. I'm going to check one more just to make sure. So 7/4 minus, and I'm going to use that 6/4 again. What do we get? Did it work? Yes, and the difference is 1/4. All right, we're going to give you a formula now. Okay. So make sure you write down that green formula. These are subscripts. They should be written underneath. It's notation. Okay. It looks like that when you write it. You write it kind of low. Just like an exponent is high, a subscript is low. So as long as you have the formula and you know what all the parts mean, you should be able to plug in and use the formula and manipulate it and to solve for any of its variables. Okay? So let's talk about what this means. This is the last term. Okay, so the last term is a sub n. A sub 1 is the first term. No matter where we see that in any formula, it usually stands for the first term. N is the number of terms. That's not a hashtag. We used to use it to say number. Number of terms. Maybe we need to write the word number. Okay. All right. And then D is the common difference. I usually will just say difference, but common difference. All right. It looks like we're only going to do one example like example 5. Because it's kind of on the longer side. All right, let's check it out. So we're supposed to write the first 5 terms, determine whether the sequence is arithmetic. If it is, find the common difference. It says assume n begins with 1. So what they want me to do is I'm going to say a sub 1 equals, and I'm going to plug a 1 in for n. And then I'm going to find a sub 2. And then I'm going to find a sub 3. And then I'm going to find a sub 4 and finally stop at a sub 5. They gave me this little formula. That's the formula for this sequence. Okay? So I'm going to plug into that formula. So what is my n value? What did we say? 1. So 4 times 1 minus 3. What's 4 times 1? 4 minus 3 is? 1. Good. All right. What number am I plugging in next? 2. 4 times 2 is? 8 minus 3 is? Do I really need to write down that intermediate step? I hope not. Okay. If you do, that's okay. All right. 4 times 3 minus 3. So what's 4 times 3? 12 minus 3 is? 9. Good. 4 times what this time? 4. What's 4 times 4? 16 minus 3 is? 13. All right, and then 4 times 5. What's 4 times 5? 20 minus 3 is? 17. So this right here is the sequence that they're looking for. So that was the first 5 terms of the sequence. Now I still need to determine if the sequence is arithmetic or not. Okay, so that means I need to do my common difference like we did in the last few examples. So my difference equals my first or my second minus my first, which is 4. And then I'm going to keep testing, right? Then I'm going to do 9 minus 5, which is still 4. All right, and then 13 minus 9, which is still 4. So did that one turn out arithmetic?
Yes.
Yes, with a difference of 4. You see how it was just one extra little step, this extra mess over here? We had to create the sequence. Not going to happen very often on the homework, but we need to make sure we can do it. All right, now we're going to use the formula. Okay? And you just had to turn the page on your formula. I'm going to write the formula down again up here. Plus n minus 1 times the difference. All right. All it wants us to do is find a formula a sub n for the arithmetic sequence. So I'm going to plug these in, and it wants a generic formula. That means we're not going to solve for the n value. Okay? So I'm literally taking this formula, plugging in the parts that I know. So a sub n equals, what's my first term? -1, perfect. Plus n minus 1 times, what's the difference? 5. Probably should simplify it. So what are we going to do with that 5? Distribute. Good. So we've got a sub n equals -1 plus 5n minus 5. I could probably simplify that, right? So 5n, what's -1 and -5?
-6.
That's what they're looking for. Like in the last example, it gave us this and wanted us to create the sequence, right? So it could have, it probably came from a formula, or we could have gotten it from the formula there. All right, let's try it again. Okay, so I'm using that same formula. The a sub n equals a sub 1 plus n minus 1 times the difference. All right, so what's going in for my first term? 2, good. All right, so 2 plus n minus 1, what's your difference?
3.
Good. What are we supposed to do now? We're going to distribute n, so we've got a sub n equals 2 plus 3n minus 3. 3n minus what?
1.
1. Good. All right, this one's a little bit different on the next example, on example 8 here. All right, find a formula a sub n for the arithmetic sequence. So we know that our formula is a sub n equals a sub 1 plus n minus 1 times the difference. Let's think about what we have, okay? I know a sub 1, right? This is a sub n is equal to 16. And then that number right there, that's your n value. I'm missing the difference. So, but I can calculate it, given what I know. Okay, so what am I going to put in for the a sub n?
5.
16.
Yeah.
Good. All right, what's your a sub 1? -4 plus, what's my n value?
5.
5. Good. So I'm going to solve for my difference, and then I'm going to put it back in with my a sub 1. Okay? Let's see. I'm going to take the 4 because I'm going to try to do as little work as I can possibly on this. I'm going to move the 4 over to the other side. How do I do that? Add, what do you get?
20.
20. Good. And 5 minus 1 is? 4. So what's my difference? 5. All right, so that's just D, right? I haven't found my a sub n formula. So I'm going to take a sub 1 and I'm going to take D. I'm going to put it back into this, just like we did on the last 2 examples. So a sub n equals, what's your a sub 1? -4 plus n minus 1 times 5. What do I have to do from there? Distribute. So we've got a sub n equals -4 plus 5n minus 5. So a sub n equals 5n minus what? 9. That's the answer they're looking for. Okay, let's see what we're doing on time here. Is it 58? Is that right? Oh, we got plenty of time. We're good. Huh? One more, but there's, I think we can probably get to 12, can't we? So we don't get out till 58. I thought it was like 52, but I think it's 58. Huh? Is it 58? Is that right?
Yeah.
Okay. All right. The first 2 terms of the arithmetic sequence are given. Find the missing terms. They want us to find the 9th term. Okay, so what we're looking for is a sub 9. We're still going to use a sub n equals a sub 1 plus n minus 1 times the difference. What's a sub 1? 3. Plus, what's my n value? They told it to us right there. 9. I also can calculate the difference, can't I? Because don't I have the second term and the first term? So my difference would be 13 minus 3, which is what? 10. Do you see how we're manipulating that formula in a whole bunch of different ways?
Yeah.
Okay? All right, all we're looking for here is a number. So let's see, 3 plus, what's 9 minus 1? 8 times 10 is 80, or if you add the 3 to it, we get 83. All right, one more type of sequence here we're going to talk about today. And I don't know what it is. SBAC likes this one. So those of you that are juniors, sophomores, you need to still listen because we won't do this in calc next year. They love recursive sequences on the SBAC. I guarantee at least one question. There's probably going to be 4 or 5 on sequences and series. All right, so did you have to fill in blanks? Okay, so recursive sequences where you're given the first 1 or 2 terms and the other terms are defined using the previous term. That's why it's recursive, because we use the previous formula or the previous answer to create the next term. Okay, so what they give us here, and it seems weird, the formula looks weird. So they gave us the first term, and then to create the sequence it says, take the term you have, and then that's going to get you the term beyond it. Okay, so that plus 1 means I'm going to go beyond 1, because if I put a 1 in there, 1 plus 1 would be 2. Okay, so to get my second term, it says take the term before it, so my previous term is going to go in, and then finish the formula, plus 3. So it's 15 plus 3. 18, perfect. To get a sub 3, I take the 18 and put it in. Plus 3 is going to get me what? 21. A sub 4, I'm taking the previous term value, putting it in. What do we get? 24. Good. A sub 5, put in the previous term. What do we get? 27. And you see how the first 5, we already had the first one? So we don't have to do 5 of those, we just have to do 4. All right, let's try it again. This one's weird. Okay. It gave me the 0 term and the first term. Okay, technically the 0 term is the first term, but what it's saying to do here, it's saying to get your term number, take the 1 2 before it and the 1 1 before it. Okay, so to get a sub 2, I take the one that's 2 before it, which would be a sub 0, so 1. And then the one that was 1 before it, which would be a sub 1, which is 1. What's 1 plus 1? 2. So now for this one, it's kind of strange. I'm going to take the 2 terms before it, right? Which if I wrote it in the right order, I'm taking both of those and adding them up. This one doesn't happen very often. So what's 1 plus 2? 3. A sub 4, which is technically our 5th term, but we're going to go one more just to make sure we've seen the pattern. I'm taking the 2 before it. So 2 plus 3 is going to be what? 5. A sub 5, I'm taking the 2 before it. So 3 plus 5, which is 8. And it could keep going. They wanted the first 5 terms, which are technically probably all of those. All right, probably with that 1 too. This one is actually a famous one. It's got a name. The next term would be 11. It's called the Fibonacci sequence. This is one that's found, Fibonacci, I think it's like that, something like that. It's found in nature a lot. Okay, no, not one, only one eye. Okay. All right, last one we're going to do today. Okay, last recursive one. And then the homework's posted in haiku for you. We've got our second term would be the first term plus 1, it looks like. So I'm going to do 6 plus 1, which is what? Good. A sub 3 is going to be, what am I going to plug in? 7 plus 1, which is 8. What am I going to plug in this time? 8 plus 1, which is 9. And to get my 5th one, I'm going to do 9 plus, I'm giving you the answer, 9 plus 1, which is 10. There's your first 5 terms. Okay? All right, look. I want everybody to look in haiku. Okay. And your homework assignment is posted there. You need to, in your notes notebook, okay?